Welcome to Dev Bootcamp Life, the podcast for new software engineers that want to level up to land their first job, or if you already landed your first job, we'll help you level up here so you become the best software engineer on your team. My name is Juan Lizarazo.
And I'm Jared Potter. And today, we're going to be talking about a really interesting topic that Juan's bringing to the table. What's the topic today, Juan?
Yeah, so something that I noticed with our students, with my students, when they're working on React, right, and they use a lot of classes and create components, but then they have struggles that are not really React issues. They know React, they know the React APIs, but I noticed they struggle with some JavaScript stuff, but mostly I noticed that they struggle with the following, which is object-oriented programming. So they're using classes, they're also using functions and hooks and all these different things that is specific to React. So today we're going to keep it like more agnostic, not really React, but we're going to talk about object-oriented programming and object-oriented programming in JavaScript, because I noticed that this is a gap with these new software graduates. And the thing is, like, this thing comes in interviews a lot. And once you pass the interview, once you get hired, most likely the company is going to be using it to establish, right, how things are created, right? So we're going to talk about that. So remember, audience out there listening to this, your homework today is to write things down and then go and learn everything you can, because in 30 minutes, we're not going to be able to turn you into an expert on object-oriented programming. And one more thing, whatever platform you're on, don't forget to follow us so you get notifications every time we publish a new episode. So yeah, Jared, object-oriented programming, I would say that it would be a good idea to start probably with let's try to define it, right? Let's try to define object-oriented programming. Let's start there. Like, what is object-oriented programming, Jared?
Yeah, that's a great place to start, I think. So object-oriented programming is a methodology of programming. There's lots of different methodologies out there, like functional programming or procedural programming and whatnot. There's a lot of different paradigms, but one of the most common ones is object-oriented programming. And the most succinct way I would describe object-oriented programming is being able to map real-world objects or things to classes in a programming language. And from those classes, you can create individual instances of objects that are self-contained, right? So that's probably the most succinct way I would describe an object. Am I missing anything there, Juan?
No. I think that's good. Yeah. So kind of like because this is always confusing, and this always comes in interviews usually, right? So yeah. So you mentioned something. So we have, right? We have classes, right? We have objects. We have object-oriented programming, and we have instances. So I think we could start defining these four. So let's just start. So you define object-oriented programming. One thing that's important is a lot of people refer to it as OOP. So anytime you know about, like, hey, did you know anything about OOP, or a job description says OOP, they're meaning object-oriented programming. And yeah, as you said, pretty much it's it's just building a software program, right? And you split it into functional, reusable pieces of code, right? And those pieces of code are blueprints, and those blueprints are really the class. So this is like look how things are coming together. So object-oriented programming, right? We split into functional, reusable pieces of code that are called blueprints, right? And these blueprints have a term that is a class, right? So a class is I like just to define class, is a blueprint which are used to create objects. Yeah. How would you define class, Jared? Like, what do you think about class? It's always hard to define things, but this is such a fundamental thing that everybody needs to know it.
Yeah, absolutely. I mean, I share that same definition with you. And I think from episode 2 or 3, when we talked about the interview questions, this is one of the number one interview questions you're going to be asked is, what's the difference between like a class and an object, or how would you define a class? And like you're saying, defining it as a blueprint to create the instance of an object is very spot on. So one thing I'm kind of curious about is, like, why in a lot of JavaScript education or these boot camps, perhaps there's less emphasis up front on object-oriented programming in JavaScript. Like, why is JavaScript, why is there less emphasis in the beginning about object-oriented programming in JavaScript compared to perhaps other languages like C# or Java?
Well, the thing is that, so even though, like, with newer syntax, so since 2015, JavaScript supports a nicer syntax that is very explicit with the definition of classes, inheritance, all these different things we're going to talk about today. But something that that is known in JavaScript is JavaScript it tends to be named as a functional language, right? And even though anybody learning, for example, React, they create classes, or Angular, they have to create classes. They're using OOP, right? But usually there's two things, I think. One thing that it could be overwhelming, right? Because you could spend a whole semester just learning about object-oriented programming and creating abstractions. We're going to talk about abstractions, right? Another concept I'm introducing you to. But I think it's just too much content. And in 6-7 months, you cannot learn object-oriented programming and learn how to program and learn React and learn unit testing, right? There's so much to cover that's why when this gap starts to be present, right? So in my opinion, I think it's because JavaScript, you can get away without diving so much into it, but you're not going to be really great at building software if you are not aware of these different software paradigms, right? Like object-oriented programming or functional programming. What do you think, Jared?
Yeah, I can agree with that. I think that in JavaScript specifically, there's a couple of aspects that lend to why object-oriented programming gets kind of pushed back a little bit. One of them being is the object literal, because in JavaScript, you can just create your own object and assign the fields to it. You're like, a new developer might ask, why do I need to create all this extra code for something I can just make in line with an object literal right there, right? I think that's one of the reasons. I think another one of the reasons is that when newer students are just trying to grasp the foundations of programming, variables and scopes and conditionals and for loops and all these different things, that when they hear all these terms that are associated with object-oriented programming, some of them we had mentioned, like inheritance or abstractions, or a couple of the other ones are polymorphism and encapsulation, right? These sound like big, scary words that really sound like, oh man, that's something that's really complicated, right? And I think that's part of why it gets avoided earlier on.
Yeah.
But why don't we, go and I guess, tackle some of those bigger words and kind of really break them down to what they really are. So which one do you want to start with, Juan?
So before that, I want to dive into that, but one of the issues I always see is that, let's say when I do interviews, I ask, okay, object-oriented programming, right? And then it's kind of like, okay, so this question is very common too, which is, what's the difference between a class and an object, or a class and an instance, right? And it's kind of confusing because, the class is the blueprint. Okay, and what's a blueprint, right? So let's make the difference between these two, and then let's start going through abstractions and building up on these two concepts. So instance, it could be hard to define, because instance, object, right? All this stuff. But a class, we say it's a blueprint, right? But a class really is a single and unique, right? Unit. An instance. Yeah, an instance is it's a unique unit, right? Of a class. That's an instance. That's kind of how I remember, unique unit of a class, right? So the blueprint defines it, and you can create multiple unique, right, units. Unique unit. That's a keyword. Write it down. Okay. Object, because in JavaScript everything is about objects, right? So it's a bundle of related behavior, right? So in JavaScript, an object is an instance, right? Even the object literals. An object literal is an instance of the class or the base class object, which is native to JavaScript. So anybody listening out there, just go write object with capital O in your console, in your terminal, in JavaScript, like in Chrome or Node, and you will see that you can get the object.prototype, or you can get these different definitions about that. Okay, so that's kind of like the one key concept that I wanted to differentiate. And before we dive into I would say let's start with abstraction, since it is so related to classes. So Jared, one thing, you want to add anything to instance, object, class? If not, then let's start with abstraction. What do you think?
Yeah, no, the small bit I would add is, just kind of perhaps analogize it to the real world. Like, think about, let's say you have a blueprint to a car, right? Well, that blueprint is going to stay the same no matter what. But with that blueprint, you can create 100 different cars. But then on those 100 different cars, if you wanted to change aspects about them, like the color, or maybe upgrade the seating on the inside, all sorts of different things, the class, the blueprint is going to stay the same, and the different objects, the different cars, they can change, but they're independent of each other. So I think understanding that distinction there is very, very helpful. So, but yeah, let's go ahead and jump into it. Abstraction. So it's a pretty vague term in and of itself, right?
Yeah.
I think the idea of an abstraction is, I think we can even keep the idea even with a car. So an abstraction is this idea of, you can take all these kind of messy details or how things work, right? We can keep going with this car analogy. Like a car, there's all sorts of complicated things going on inside of it to make it work, right? But we've been able to abstract all those details away to a set of simple user interfaces to interact with: the steering wheel, the gas, the brake, right? The signals, all those things, right? So we've been able to abstract those away to a simpler form that we can interact with. And I think that objects and classes are the same way, right? We can pack a whole bunch of different functionality or modeling of data in a class, in an object, or a class that then creates an instance of an object. And then we can just interact with it with the public functions that we've provided. And we don't need to worry about those messy details, right? So this idea of abstraction goes beyond just object-oriented programming, right? It goes into lots of aspects of computer programming, right? And that's, again, one of the main things about classes is we can put functionality into classes and the instance objects that come out of them, and be able to reuse them without needing to know the details. But how would you add to that, Juan? Abstraction.
You're opening a Pandora's box here, because you're introducing us now to this bundle of concepts, right? So abstraction, yeah, pretty much you defined it, and you were very explicit and very detailed, right, with it. So I really like what you said. I would just say one way to summarize it, when I teach my workshops and I talk about abstractions, I just tell my students, you know what? Abstractions, they're just a representation of the real world. A representation, that's it. So for example, you're talking about the cars, an abstraction of it would be a class. You define a class, like you call it car, and that class, it's code, but look, car is representing something of the real world. And that's how we build software. Every time we build software, we're representing something of the real world. And I don't mean like physical objects. Sometimes it could be concepts, right? So you could be like, you know what? I'm going to create a love class, and it's an abstraction, real world, because we have this concept of love, right? But when I mean about the real world, is like outside of the coding world, right? It's kind of like we're grabbing this and putting it in the coding world, right? And now, one thing you introduce, right, is that you talk about like obscuring, right, the details of it, the inside, how it works, right? There's only just a public API. So you're hiding the implementation details of that. And that really is encapsulation, which is, I think, is the next natural concept to explain about object-oriented programming. So let's talk about encapsulation. But first, I'm just going to remind our audience. Let's remind our audience about our Twitter account, where we post content, we post JavaScript tips, we post things we like, right? Things we like there. And also, like, it's a way for you to be in touch with us. I have, like last week, I had students reach out and through Twitter about things about the content I create, or just, reaching out to let us know how we're doing, provide like feedback. I mean, it's a way for us to connect. We're open there, okay? So I'm going to go ahead and share the screen here. Anyone watching here on YouTube, you can see our Twitters here.
Yeah, you guys can find me at twitter.com/Jared Potter. That's JaredPotter.
Awesome. And you can find me at twitter.com/Juan Lizarazo G. So I'm going to spell that out for you. But because it's so hard to spell, we're putting the links to these in the description on whatever platform you're listening this on, okay? So just go to the description and just click it and follow. It's easier that way. If you don't have Twitter and you're on YouTube, just subscribe. This is on YouTube as well, or whatever platform you're on. So my Twitter is, it's JuanLizarazog. Okay. And yeah, reach out and let us know how we're doing and ask us questions. I mean, whatever, we're open there. We're there for you. Okay. Awesome. So let's continue. Jared, I think I lost your video. Are you still there?
I'm still here.
Okay,
I don't know
now
why
your video
it stopped.
came back. Something happened.
Yeah.
There was a little bit. Okay, awesome. Let's continue. So abstractions.
We were going to get
Encapsulation.
encapsulation. Yep.
Encapsulation, yeah. So how do you define encapsulation, Jared?
Yeah, I think there's two parts to encapsulation. I'll try to be really succinct here. So one part of encapsulation is this idea of being able to contain certain functionality that's shared across all of the children objects inside of one class, one file. It's really clear that this file contains that. The second part is that each object that's created is individual, it's isolated instance from any other instances, right? So those are the two bits from encapsulation that I recall.
Yeah, no, that's really good. Yeah, encapsulation is. I like to think about, and this is also kind of introduces to more concepts, but like encapsulation goes along a lot with responsibilities, right? Like so one way, like when you are designing a class, always think of like the car class is going to be in charge of defining how a car works or how a car operates or how a car is created. That's it. But then that means like when you have a motorcycle, right? You're not going to put in the car class. It's kind of like, no. Car encapsulates about the car, create a motorcycle class, right? So now we're separating things, right? And because we're encapsulating, right? The behavior, I don't know how the car starts. I can just call car.start, right? And you start like an instance. So you say I create an instance and I call the method start. I don't know how it starts. And it's just like in the real world, Jared. So anybody out there listening, I want you to think about this. You get into the car, unless you're you're an expert or a mechanic, right? But average user like me, we get into a car. I just put my key and turn it, right? And the car just starts. How it starts, I don't really know. I don't know the implementation details. I know there's an engine. I know there's a key. I know there's power. But it magically starts, right? The encapsulation is happening right there. The car encapsulates how it works, and the user does not have to know how a car works to buy and use a car. And that's the reality on the world today. Right now, we're using this system, right, to record this. We have no idea really how it works. It's encapsulating this. It's obfuscating the implementation details. But now there's also responsibilities, right? Because a car, let's say I need to fly, right, to South America. I'm not going to go fly in a car, right? Because no, the car encapsulates, right? But it also has certain responsibilities, certain boundaries. So this introduces, right, to the next natural concept, which is separation of concerns. That has to do a lot with responsibilities, right? And this is part of a bigger thing that we'll cover in another episode. But separation of concerns, like what do you think about concerns, Jared? Have you heard about this before?
Yeah, certainly. Separation of concerns covers so many different topics of computer science and software engineering that you're going to see out there, right? One, just so people kind of get a really basic idea of what separation of concerns is, think about your HTML, your CSS, and your JavaScript, right? These are three different files, and each of them are managing a different concern, right? The HTML is like the structure and has a certain amount of the functionality. Your CSS is all about how it looks and how it's presented to the user. And the JavaScript is going to be the interactivity that you might have on your website or the ability to post data somewhere, right? So the separation of concerns is each file kind of has its own responsibility, right? So in the context of object-oriented programming in JavaScript and classes, right, we want to be able to say, hey, for this car class, things that are specifically related to the car, we want to stay in that car class. But things that don't have to do with the car, but maybe are kind of related, you know, we might think a little bit more about how we're architecting this application. Like, do we want to have that in there, or maybe we want to put it into a utility class or something like that? What's your take, Juan?
Yeah, just like to add, like for anybody out there listening to our audience, like, so you can relate to this. If you're using Angular or React or Vue, right? Think about this like for responsibilities, like when you create a component there, right? Because you're most likely, if you listen to this, you most likely have some sort of experience with this, right? Because you're doing front end most likely. So when you're using these, you create components, right? And let's say you create a button component. You don't decide and say like, okay, the button component is going to include the form. No, right? You stop and you're like, no. The button component is just a button. And then the form is maybe the form component. So we have two different concerns. We are concerned about the form right? And we're concerned about the button. So we have two concerns, separate concerns. So apply what you just said, Jared, that this is key. This is how our audience can get in the mindset when they're architecting things. Like, does these, let's say we need to add a rainbow in the application. Does the rainbow belong to the button or does it belong to the form? And you're kind of like, doesn't belong in neither of those really, right? So we can just decide that we can just say like, no, we don't really want to put it there. We just create a new component, and that's like a new concern, new component, right? If you're doing React and you're like, yeah, it's not a class, yeah, it doesn't matter. It still is a different concern, and you're doing components, right? If you're using hooks, right? But if you're doing classes in React, then yeah, it's a separate class, it's still separate component, separate concern. But that's such an important principle, and that's how I go when I'm building software or designing. I'm like, does it belong here? Because sometimes I don't know. I'm like, yeah, it's not a concern. This goes somewhere else. I don't know what the somewhere else is, but I know that it's a different concern because you should be defining those boundaries. Okay. Something that that I like to point out is for if this is so much and is so new to you, go to a website that I like. Just Google MDN. Is the Mozilla Developer Network. So type MDN space object oriented programming, and then with that just go ahead and open the link, and that will show you like a more comprehensive introduction to these concepts we're covering, right? Because remember, we're here exposing you, throwing knowledge at you, and your homework is to write it down, learn it, and go research everything you can about it, and then you're gonna level up. We're exposing you, okay? But yeah, that's concerns, Jared. Like what our next concept would be that we should cover.
Yeah, I think one thing that's worthwhile discussing in this while we're talking about object-oriented programming is the this keyword inside of a class or an object, right? So this is this is something that's very confusing to many students. They don't understand when to use it, why to use it. I'm sure lots of students will get, cannot access property of undefined when they're trying to use this. So what is this keyword and how does it relate to what we're talking about?
Yeah, the this keyword, I mean, there's two things with that. So the this keyword, right? That's one thing in object-oriented programming in just most languages, but then in JavaScript, it goes up another level because the this keyword in JavaScript, besides being the this keyword, it also like changes. Everything has to do, when I think about the this keyword, I think about context, okay? And the this keyword can have a different meaning depending on the context, meaning you can have a function with the this keyword, and then you put that function somewhere else, right? And the context changes, right? Or you bind that function to a different context, and now this means something different. So this is such a complicated thing to understand, right? So this usually, like the easiest way for me to define it is like, if you are inside a class, this represents that object instance once the object is created out of this blueprint, right? Out of this class you have. So that this keyword is like, imagine that's the actual instance of the car. If you create 3 different instances of the car, that this is going to be different in those, but that's a way for you to refer to it inside your function. Like, let's say the start, right? The start function for the car that I was talking about earlier. This dot engine dot start, right? And now it just started the engine. But it's kind of like, that's how it is the engine for that specific car. So one thing is about context, but also like think about the specific instance you're in. And that's how I like to start boarding it without talking about binding and changing context and all the craziness, right? But you listening out there, look in Google, look it up, like these in JavaScript, meaning of these, context, binding for the these keyword in JavaScript. And you're going to get hundreds of resources that are going to help you out understand this. This is a tough one, but because Jared mentioned it, Jared, I think you have some sort of trick or some sort of easy way to define this. So help us out here.
Well, I honestly think you did a great job there. That, although, in your class, you're going to refer to this keyword, you have to really think about it as, when the functions inside of your class are being executed and they refer to this, they are referring to an individual instance of it, right? So if you create, like, let's say 3 cars, and on the second car, you call that start function that Juan just mentioned, only that second car is going to have their engine started, right? Maybe we're going to have some piece of state that says, status started or running or something like that. But the other ones are going to stay independent of that.
Yeah.
No, I mean, I would just encourage, like you're saying, go out there and do some research. And in addition to that, one thing I really encourage students to do is also go and practice it. Create a new little, playground project, or even use something like StackBlitz or any of the other million web-based IDEs, and just kind of play around with this keyword. And also in the context of arrow functions, or some people might refer to them more as higher order functions. And also look up that term. You're going to might get that one in an interview.
Yeah.
But understanding how this keyword works inside of just a class object, but then how does it also work when you start using callback functions, arrow functions in things like map arrays, right? How does it change then? It's really important. Or even for a lot of our listeners probably using React, right? If you're still using class-based components, you'll remember that you have to call this dot set state, right? But with React hooks, we don't say this at all. You don't really it's not even necessary. But yeah, like I said, the main thing I would say is go and practice these things. Learn about it and practice them, because this is going to be ubiquitous throughout JavaScript as well as other programming languages if you go and explore other places.
Awesome. This was a great discussion. We're out of time, so we're going to do two things. One thing, during the week, Jared and I are going to tweet resources where we are going to point you out to different things that we think that will help you out level up with object-oriented programming. So we're just going to post links and things like, hey, you should do this or that. So if you want to get those links, go ahead and follow us on Twitter, and we're going to be engaging there during the week. But yeah, just to finalize, a quick recap of what we covered today. Just let's point out the different concepts. So I remember we talked about object-oriented programming. We defined it, right? We talked about class. We talked about instance. We talked about object. We talked about blueprints, which was related to classes. We talked about encapsulation. What else we talked about, Jared?
We talked about abstraction. We also talked about this keyword in JavaScript.
Keywords, yeah, and the concerns.
Yep, and the separation of concerns.
Separation of concerns. So we covered a lot of things. It's like a high level, but now you have so much to go look for and learn or find whole classes on these, right? The whole materials, coursework, and you're gonna be good with this. But yeah, this was really awesome. First time we are getting very technical since we're building up in the previous episodes. If this is the first episode you're listening, go ahead and go to episode 1 and start listening to the series, okay? Because they are building upon the previous one. So we're gonna keep building so you can level up and become the best engineer on the team, or land your first engineering dream job. So yeah, that was awesome for today. This was Juan Lizarazo.
And this was Jared Potter.
And we'll see you next week. Thank you so much.
Take care.